All right, guys, we are on day 5, and we're going to solve radical equations today. All right. What we have to remember is that we have to isolate our radical and what's underneath it. All right, so that's our first step, to identify and isolate our radical and what is underneath it. And we're going to get that by itself on one side of the equation. All right. Once it's by itself, we have to remember that if it's a square root, okay, we're going to square each side to get rid of the square root. All right, so you raise each side to the root number in the problems. Therefore, if it's a cube root, we'll cube each side. If it's a fourth root, we will raise each side to the fourth power, and so on. Okay. One thing that we have to remember that a lot of people will forget is that once we solve, we have to check for any extraneous roots. Extraneous roots are solutions that get rejected. All right, so they are solutions that get rejected because when plugged into the original equation, they do not make sense. All right, or they give us an error, and you'll see. Okay, so here we go. Number 1, it says solve each of the following equations. Okay. So you're going to notice, and I'm going to use my highlighter on our notes today. I'm going to highlight our square root, okay, or whatever our radical is, and what is underneath it. And remember, that has to be alone on the left-hand side or right-hand side, whichever side it's on, okay, before you can go ahead and remove it. And so in this case, the radical and what's underneath it is the only thing on this side of the equation, and so we're ready to go ahead and remove it. So the opposite of rooting is squaring. And so we're going to go ahead and square each side. So we're going to go ahead and put this in parentheses and square it, put this in parentheses and square it. And that's why that has to be isolated, okay? And so we're going to take that square root and we're going to take that square, and they're going to cancel each other out, okay? And so we end up with 2x minus 1 equals 4 squared, which is 16. And now it's just a basic equation. So we're going to add 1, and we get 2x equals 17. And then we're going to go ahead and divide by 2. And x equals 8.5. And most people will think that we're finished here, but we're not, all right? We have to remember that we have to check, because we could have solutions like 8.5 that when plugged into the original don't make any sense. All right, so we're going to go ahead and on the left-hand side, we're going to type that into our calculator. So we're going to type in square root of 2 times 8.5 minus 1, and we're going to hit enter. And when we hit enter, we end up with the answer of 4. And we have to see if it's equal to the other side of our original equation, which is 4. And it does. And so there's a little check, and then it checks out, so we can keep this as our answer. And we have no extraneous solutions in this one. All right, so the next one. So this one's actually in good shape. Here we have a cube root instead of a square root. All right, but the good thing is that the cube root and what's underneath it is already isolated. It is already by itself on the one side of the equation. So we are ready to go ahead and remove that cube root. And so we're going to remove it by raising each side to the third power. This cube root will cancel out with the cube, okay? They undo each other. They're opposite operations. And so all we're going to have left on this side is 4 minus 2a equal to a negative 2. Make sure you use parentheses around it when you raise it to the third power, and you should get negative 8. Okay, and now we just have a basic equation to solve. So we're going to go ahead and subtract 4. And we end up with negative 2a equal to negative 12. We're going to go ahead and divide by negative 2. And that way we end up with a equals, be careful, a negative divided by a negative is positive, 6. Okay, except we're not finished. We have to remember that there could be extraneous solutions in these radical equations. So we're going to go back up and we're going to plug in, okay? So we're going to do cube root. Cube root is under math, okay? And under that cube root, you're going to type in 4 minus 2 times 6, okay? And we're going to end up with negative 2 when we hit enter. And if we look back at our original equation, this was equal to negative 2. And so the left side equals the right side, and we can keep a equaling 6 as our answer. Okay. Next one up. Number 3, so we're going to take a look at our radical, which is the fifth root here of x. Bad news, it's not isolated. There's an 8 stuck to it who's not underneath that radical. And so we're going to have to go ahead and isolate what we highlighted, our fifth root of x, okay, by getting rid of that 8. And the way we're going to get rid of the 8 is to recognize what operation it is stuck to our radical with, which is multiplication. So we're going to divide by 8. And that way, our fifth root of x is now isolated. And on the other side, negative 4 divided by 8 is negative 1/2. Okay, or negative 0.5, doesn't matter. And now we're ready to go ahead and remove that fifth root by raising this side to the fifth power. And we're going to raise this side to the fifth power. Okay, the fifth root and the fifth power will cancel, leaving me with an x equals. And in parentheses, negative 1/2, close the parenthesis, raise to the fifth power, hit enter, math bracket if you don't like the decimal, and you end up with negative 1/32. Okay. Except we're not finished. We have to remember that these radical equations can have extraneous solutions that get rejected. And so we're going to have to go back and plug in, okay? So we're going to go ahead and type in our 8. Okay. Actually, in this case, it might be easier not to type in the 8 just yet. Okay. But maybe it'd be easier to do the fifth root first. So we're going to do the fifth root. So you have to actually type in 5 first, and then take your calculator, go to the math button. And in your math button, or under that math menu, okay, number 5 is what they call a general root button. Okay. And so if you type in 5, that will be the number in the crack. Okay. And underneath that fifth root, you type in negative 1/32 or divided by 32 and hit enter. And that should come out to be negative 0.5, but don't forget you got that 8 in front of it. And so now you have to multiply that by 8. And when you do, you get negative 4 on the left-hand side equal to, if you look up to the original equation, there was a negative 4 on the right-hand side. And so it does check out. And so no extraneous solutions here. We can keep our solution. Okay. All right, let's go ahead and take a look at number 4. Oop, I get this weird thing where it doesn't move with it, but we'll try that. Okay. So in number 4, I'm going to use my highlighter, and I'm going to go ahead and highlight my square root and what's underneath it and realize that it is not isolated yet. So in order to get it isolated, I have to remove that plus 3. So I'm going to go ahead and subtract 3. That way it's gone from this side, and I'm left with the square root of 2x minus 3 equal to, now x and 3 are not like terms, so it's going to have to stay x minus 3. Now I'm ready to go ahead and remove my square root by squaring both sides. The square root and the square will cancel, leaving me with a 2x minus 3 equal to, now on this side, we know a binomial that's squared is kind of in a condensed form and that we have to expand it in order to put it back together. If you're a box method, you would take your box off to the side and put x minus 3 together with x minus 3, or you can go ahead and do the rainbows, okay? So the 2x minus 3 here will stay, equal to x times x is x squared. Then you have a minus 3x and another minus 3x for a grand total of minus 6x. And then we have a negative 3 times a negative 3, which is a positive 9. Okay. You notice that we have a square term, and anytime we have a square term, we're most likely going to have 2 answers, and we have to get it equal to 0 in order to find our 2 answers by factoring, completing the square or quadratic formula. So I'm going to go ahead and subtract my 2x. I'm going to go ahead and add my 3. And now I have x squared minus 8x plus 12 equal to 0. Because the directions don't say anything about nearest tenth, nearest hundredth, simplest radical form, I'm going to assume that this is factorable. So I'm going to set up my x box. I'm going to multiply to 12, and I'm going to add to negative 8. And my numbers that are going to do the job are 6 and 2 and -6 and -2 in order to get that -8 at the bottom. And when I multiply those, I get my positive 12 at the top. So they check in both. And so this is factorable. If it wasn't, I could go back and check for a mistake. Or I could go and if I can't find a mistake to make it, work out and be factorable, then I could always go and resort to quadratic formula. But this is factorable because I found the number. So I'm going to split it into x minus 6 and x minus 2. And I'm going to end up with a solution of x equals positive 6 and x equals positive 2. Okay. Again, I'm not finished because I have to go back up to the original and check it. So on this side, I'm going to type in the square root in my calculator, and I'm going to put 2 times 6 minus 3. And then not underneath the radical is a plus 3. Okay. When I hit enter, I should end up with 6 equaling, and if I go back up, on the right-hand side was an x, and my x is 6, and so this does check out. So x equals 6 can stay. All right. On the other side, my solution of 2, I'm going to go ahead in my calculator and draw and put a square root in there. 2 times my answer of 2 minus 3, and outside that radical, I'm going to write plus 3 or type plus 3 and hit enter. And my answer comes out to be 4 equal to, if I go back up to my original equation, that's an x, and my x on this side that I'm checking is 2. And we're going to notice that 4 does not equal 2. And therefore, this answer is actually going to get rejected because it does not check into the original equation. Okay? And so we just have an answer of x equals 6 and an extraneous solution of x equals 2. Okay? And that's why it's important to check our solutions. All right, let's head to number 5. And in number 5, we got a lot going on. But remember, our first step is to look for the radical, okay? And here is our radical and what is underneath it. And we're going to notice that it is not isolated, all right? So we have to subtract x to get it isolated. So I'm going to go ahead and subtract x to the other side. All right, so what I'm going to have is the square root of 6 minus 2x equal to, and I see parentheses, so I know to distribute, and that's going to give me 2x plus 30 minus that 9 and minus that x. And now I'm going to clean that right-hand side up. So this side's going to stay for now until this is cleaned up. And so I can see a 2x minus x is just x, and a positive 30 minus 9 is positive 21. And now I'm ready to go ahead and remove my square root by squaring each side so that the square root and the square cancel, leaving me with 6 minus 2x equal to, we have that same situation where we have a binomial squared, so we have to go ahead and expand it and write it out twice. And then it's up to you how you want to put it together, if you want to use the box method or if you want to use the rainbows, okay? So this 6 minus 2x is going to stay equal to x times x, which is x squared. That's 21x, and this is 21x for a grand total of 42x. Oops, I forgot my 2. And then 21 times 21 is 441. Okay, again, you have a square term, and we know that we're going to have 2 answers then. And we can't get them unless we're equal to 0 to use any of our 3 methods of factoring, complete the square quadratic formula. So I'm going to go ahead and subtract 6. And I'm going to go ahead and add 2x. And now I'm going to go ahead and see what I have. I have an x squared. 42x plus 2x is 44x. And 441 minus 6 is 435. And now we are equal to 0. Again, the directions don't say anything about nearest anything or simplest radical anything. And so I'm going to go ahead and assume again that this is factorable. Okay. Our multiply is quite a big number, so I'm definitely going to use my calculator and the table so I can find my numbers easier and faster. Okay, and our add is that 44 in the bottom. All right, so in my table for my calculator, I'm going to go ahead and type in y equals 435 divided by x, and then go to my table so I can see all the pairs of numbers that multiply to 435. All right. And we're looking for them to have a difference of 44 between them, or to make 44 if I add them. All right, and you're going to be scrolling down a little bit. All right, first number that maybe comes close is 5 and 87, but that's like a difference of 82. So I'm going to keep going. There's a bunch of decimals that I don't even have to worry about. And the next set of numbers that come and work are 15 and 29. And if you think about 15 and 29, or you want to check them in your calculator, 29 plus 15 is 44. And so I'm going to keep them both positive, because when I add them, I get 44. And when I multiply them, I get positive 435. And so they work. And so I'm going to go ahead and factor my easy trinomial into x plus 29 and x plus 15, and we are equal to 0. All right. One solution comes out to be negative 29, and my other solution comes out to be negative 15. And now I got to go back and remember to check them, because with radical equations, they're not always checkable. Okay. And so here we go. Going all the way back up to the top of my original equation, I'm going to type in my calculator a square root, and underneath there I'm going to put 6 minus 2 times negative 29. Outside of that square root, so I have to arrow over, we're going to put plus my x value, which is negative 29, and I'm going to hit enter. And what I get is a negative 21 equal to. So now I got to go back up. I have to look at the right side of my equation. And I'm going to go ahead and do 2 in my calculator, parenthesis, my x value, which is negative 29, plus 15, close it, minus 9. Okay. When I hit enter, I get negative 37, and we can see that the left side does not equal the right side when negative 29 is substituted into the original equation. And so this is an extraneous solution, and it has to get rejected. Okay. Now I'm going to go ahead and try my other solution of negative 15. So going all the way back up to the original equation, okay, we're going to go ahead, and I got to scroll up so I can read on my screen a little bit. Okay. And we have square root of 6 minus 2 times negative 15. Okay, arrow over, so you're not underneath the radical anymore, plus your x value, which is negative 15 that we're testing now. And when I hit enter, I end up with negative 9 equal to, now we got to go ahead and type in the right-hand side, so 2, parenthesis in our calculator. The x value is negative 15 that we're checking, plus 15, close it, and then minus 9. And when you hit enter, you get negative 9. And so this one checks out. And so we can keep the solution of x equals negative 15. All right. All right. Looks like we got one more to go on this side. So I'm going to go ahead and move up. For some reason, my work doesn't want to scroll with my paper, but that's all right. All right. Last one. Okay. So I'm going to find my radical. And what is this underneath it, and make sure that that is isolated, and it's not right now. So I have to go ahead and add 2 to both sides, so that I end up with my radical of x plus 6 all isolated, equal to my other side, which is 2x plus 2. Those are not like terms, okay, so they cannot combine. All right, now that I'm isolated, I'm going to go ahead and raise each side to the second power, so that that square cancels out my square root, leaving me with just an x plus 6, equal to, and we have the same case of what we had in the last 2 questions, a binomial squared. So we have to go ahead and expand it and put it together. All right. So I'm going to end up with 2x times 2x, which is 4x squared. That's going to give me a 4x, and that's going to give me a 4x, so a plus 8x. And then 2 times 2 is plus 4, equal to an x plus 6. All right, again, I have a square term, so I'm going to end up with 2 answers, but I can't get them unless I factor, complete the square, or quadratic formula. and therefore that's why I have to get equal to 0. So we get 4x squared. 8x minus x is a plus 7x. 4 minus 6 is a negative 2, and we are equal to 0. Okay. Again, I think that this is factorial based on nothing in the directions indicating that I would end up with not nice or irrational answers. It is a hard trinomial though, and so we're going to go ahead and multiply to negative 8 and add to 7. And our numbers are going to have to be 8 and 1, except the 1's going to have to be negative. So that if I multiply them, I get negative 8, and if I add them, I get positive 7. Okay, but again, remember he's a hard trinomial. So the 4x squared gets rewritten, then my plus 8x, then my minus 1x, and then my minus 2 equals 0. We're going to group and group since it's a hard trinomial, and we're going to pull out the 4x out of the first group, left with x plus 2. Out of the second one, watch that negative, so we have to pull out a negative, and the only other number in common is a 1. Left with x, and don't forget when you pull out the negative, that flips the sign, so this has to be a plus 2, so that if you distribute the negative 1 back in, you get what you started with. Plus, they have to match, and so x plus 2 becomes one of my factors, 4x minus 1 becomes my other factor, and we're still equal to 0, and now we're ready for solutions. On this side, x is going to come out to equal negative 2. On this side, we're going to have to add 1, so 1 is positive, and then divide it by 4, so 1/4. All right, don't forget the last step in radical equations is that we have to check. So going back to the original, on the left-hand side, we're going to do 2 times negative 2, which is negative 4, equal to my right-hand side, which is the square root in my calculator of negative 2 plus 6, arrow over, and then minus 2. And when we hit enter, we end up with 0. And this does not check out, and so negative 2 is going to be what we call an extraneous solution. Okay, let's go ahead and check 1/4. And so if we do 2 on the left-hand side times our answer of 1/4, we end up with 1/2 equal to, on the right-hand side in our calculator, square root of our x value, which is 1/4, plus 6, arrow over, hit minus 2, and hit enter, and we end up with 1/2. And so this one checks out, and we can keep our answer of x equals 1/4. All right, I will see you guys on the back side of notes.